The hydroplate theory, it's developed by Dr. Walt Brown. He got a PhD from MIT in mechanical engineer. He was a West Point grad. Was an Army trooper, Army Ranger, paratrooper, taught at the U.S. Air Force Academy, ran the Benet military lab where he had dozens of PhDs working for him. And he's going through South Dakota, and he hears that, this is in the 70s, mind you, in the 70s, and he heard that somebody found an ark on the mountain. He thought, what a crackpot, because he's an evolutionist. But he thought, if that was true, that'd mean the whole world was flooded with water. And that would mean that there was a lot of plants and animals that got buried in mud and became fossils. He thought, wait a minute, if fossils are evidence for a flood, where's the evidence for creation? And he started to ask his PhD friends. And after 2 years, he didn't have any evidence. And so he saw in the Bible that there's fountains of the great deep, there's springs in the sea, that the earth formed the earth on the seas, that there's water inside the earth. And so he thought, if that's the case, what would happen? And so just think of the earth as a big apple. The crust is 60 miles thick, made of granite. There's a layer of water a mile thick underneath that, and then there's the mantle under there. And the mantle and the granite are touching at various places around the earth. Okay, that's the one assumption. And then the moon is going to tug on the earth. And back then, the crust wasn't broken into plates like it is today, so it just stretched and compressed. And with that, it generated heat. The heat had to go somewhere. It went into the water. Water got hotter and hotter and hotter. It wanted to boil, but it couldn't because there's no room to boil. And then at 705 degrees and 3200 psi, it became supercritical water. Where it's not really water and it's not really steam, but whatever it does, it dissolves things like crazy. So it's dissolving the granite above and the basalt below, and it's mixing it together and making salts and limestones and silicas and quartz and cementing agents. All that stuff is in the subterranean water chambers. And every time limestone is formed, it releases carbon dioxide. And there's 60,000 times more limestone than carbon dioxide in our atmosphere. And Walt Brown, he was teaching at Arizona State, and he taught with Bob Dietz. He's the guy who coined the term seafloor spreading. And he said, hey, Bob, where did all the limestone come from? And Bob said, beats the blank out of me. So where did all that excess carbon dioxide go? It just kept getting recycled in the subterranean water chambers. Okay, so the water's getting hotter and hotter, the crust is getting weaker and weaker because it's dissolving, and then eventually there's so much pressure, and Walt Brown says 372,000 psi on that water, supercritical water. Can you imagine that going out, getting to atmospheric pressure of 14.7? It's just going to explode out of there. And that's what happened on the 600th year, the second month, the 17th day of the month, the same day where the fountains of the great deep broken up in Noah's life. And that's when the crust of the earth cracked, and it went in two directions. The water exploded out of there, and that crack went around the earth, and it came together like a seam on a baseball. And people say, well, if that happened, wouldn't it leave a mark? And yeah, it did. It's called the mid-oceanic ridge. That's the mountain range that goes through the bottom of every ocean. 46,000 miles long, and it's made by stretching in two directions. You look at those, they're tension cracks. Rock is really strong compressing wise, but to pull them apart, it's not real strong. And so it just makes a straight line. Well, the mid-oceanic ridge has straight lines vertically and horizontally. How do you make a mountain range? By stretching it in two directions. Okay, so now you got water erupting out of there, you got 40 days and 40 nights of rain, okay, and you got these two cliffs that are 60 miles high, and on Earth you can only have a cliff 5 miles high before it makes it crumble underneath. Well, this is 60 miles high, crumbling into this hypersonic water that's erupting out of there. That's where we get the sediment for this, most of the sediment for the sedimentary rock. When you have sedimentary rock that doesn't have limestone in it, or doesn't have carbon in it like limestone, it's 65 parts granite and 35 parts basalt. Well, that's because the granite was being eroded on the bottom and on the sides, whereas the basalt was just getting eroded on the top. And so now that's going across you got these cliffs that are getting wider and wider and wider, and then eventually there's nothing pushing down on the Atlantic Ocean, so the Atlantic Ocean bulges, okay? And now the continents start sliding. They're on supercritical water that's 50 times slipperier than ice. Just think of it as a big air hockey table, and they start sliding. North America and South America is sliding to the west, Europe and Africa is sliding to the east, and then they keep going until they meet resistance, and then they buckle up and make mountains. That's why the major mountain ranges, the Andes and the Rockies, are parallel to that mid-Atlantic ridge, and also there's a range in Africa, similar situation. Okay, so now you got the mountains are a big mass on a small base, so they sink in, something sinks in, something's got to rise up. That's the Colorado Plateau. They can't explain that one either. Okay, it's a major mystery, and it's actually a double-sided mystery because it seems to have gotten higher and lower at the same time. Well, it's just because the magma was getting squished out from the mountains sinking and it went to the side, so the mechanism is hydraulics. They block faulted upright, and then the force is gravity. So engineers love this theory. It just makes so much sense. Okay, and so then we talked about the lakes forming. Okay, and so then similarly, that mid-oceanic ridge is rising up. Something has to sink in. That's the Pacific Ocean. That's the Ring of Fire. That's why the main trenches are in the Pacific Ocean. I mean, Mariana Trench, it's a mile deeper than Mount Everest is high. And it's got all these table mounts and volcanic activity, 40,000 of them. Table mounts or sea mounts, whatever they are, but they had volcanic activity or origins. And it even sunk in Zealandia. That's our 8th continent. It's about the size of India, and it got sunk in, and Walt Brown claimed, he predicted they'd find granite in the Pacific. And what to tell you next? Okay, so then the water that was covering the earth during Noah's flood gushed off the earth to fill in the Pacific Ocean and cut these the submarine canyons, or they weren't submarine at the time. The continental shelf was still sticking out, and it cut these canyons. Okay, and then the continents sunk down, and then the oceans rose up and buried those canyons in water. And then fast forward just a little bit. Oh yeah, the Ice Age. There's a big canyon in Greenland that's it's under 2 kilometers of ice. Well, how does that happen? Well, the water gushed off, cut the canyon, and then the Ice Age filled it up. Well, how do you get an Ice Age? Well, it needs to snow more than it melts year after year after year. Well, how does that happen? You need to have warmer oceans, but cooler continents. You need warm oceans to get the precipitation to come down, but you need cooler continents so it doesn't melt. Okay, and so how does that happen? Well, the Pacific, the oceans were warmer because all that volcanic activity, and it came down as snow. But in parts of Alaska and Siberia, they didn't have a glacier during the Ice Age because it came down as rain there. It was lower, and it was closer to the coasts. But any of the higher parts came down as snow, but it didn't melt because the continents were higher, therefore cooler. Plus, there's all that volcanic activity. There's a lot of aerosols in the atmosphere, so the heat from the sun couldn't get to the Earth's surface. Okay, and so 400 or 500 years of it snowing more than it melts, and then it didn't snow as much, and then the atmosphere heated up. Okay, and then fast forward to that, they found a standing mammoth that's frozen, standing up. That's because some of the stuff got out with such tremendous force, it escaped our atmosphere, it got super cold, came crashing down, buried the mammoth standing up, and some of the stuff was coming up with such tremendous force that not only escaped our atmosphere, it escaped our gravitational pull. And you got all this mud and dirty snowballs flying around. That's the comets. Walt Brown says that this theory shows how the comets and the asteroids and the trans-Neptune objects came from Earth, and it's been making accurate predictions, and NASA discoveries are validating this theory. So to understand the Grand Canyon, you really need to understand the Hydroplate Theory, and once you understand the Hydroplate Theory, the Earth and the solar system just snaps into focus. So you're welcome. You know, if you want any more information on this, go into Brian Nichols' YouTube channel, and I've got a YouTube channel called Solidify Your Faith, got a playlist specifically for the Hydroplate, and then Mike Snavely at missionimperative.org got a real good movie called Puzzle on the Plateau, and that ties in Bryce and Zion and Monument Valley and Canyonlands and the petrified forest. That's all part of these lakes. So I encourage you to get involved, get educated, get informed, and inform others. Praise the Lord. Have a blessed day.